Okay, let's dive into this. Welcome to today's Explainer. We are tackling one of the absolute biggest, most fascinating challenges of our time, balancing the Earth's climate scale. Today, we're going to look at exactly how humanity is trying to fix the atmosphere. And we're talking about everything from brilliant natural solutions to literally massive high-tech machines, and even peering into the highly debated frontier of climate intervention. So let's get right to it.
So is Earth wearing too many heavy blankets? I know, it kind of sounds funny, right? But honestly, it's the perfect way to really understand our current crisis. You see, invisible carbon dioxide, or CO₂, is just part of the air we breathe. A little bit of it is totally normal. It acts like this nice, thin blanket around the planet, trapping just enough heat from the sun to keep us alive and comfortable. But human activities, burning oil, gas, coal, they've pumped massive amounts of excess CO₂ up into the sky. So suddenly, Earth isn't just wearing one comfortable blanket anymore. It's buried under a mountain of heavy winter quilts. And because of that, the planet is dangerously overheating.
Here's how we're going to break this down today. First, the thickening carbon blanket. Second, nature and technology working together. Third, the geospatial smart map. Fourth, auditing the Earth. Fifth, geoengineering, fact versus fiction. And finally, number 6, governing our climate future.
All right, Section 1, the thickening carbon blanket. Let's start right at the root of the problem and look at why this excess carbon dioxide is actually destabilizing our atmosphere in the first place.
Basically, a greenhouse gas like CO₂ traps heat. And because we're adding so much of it, all that heat is getting trapped right up against the surface, triggering global warming. And we're not just talking about a few warmer days in July, right? This thickening blanket is creating profound instability. It's causing extreme weather, stronger storms, severe droughts, melting ice, the whole shebang. To stop this, simply reducing our emissions, well, it just isn't enough anymore. The blanket is already way too thick. We actually have to figure out how to pull that extra CO₂ right out of the air.
Which brings us to Section 2, nature and technology working together. Since we have too much CO₂ up there, we have to actively remove it. And to do that at the massive scale we need, we got to use a dual approach.
On one hand, we have nature-based sponges. Forests naturally breathe in CO₂ to grow, right? They lock it right into the wood in the soil. The oceans are also giant sponges. They naturally absorb massive amounts of carbon. But, and this is absolutely crucial, there is a serious limit here. If the ocean absorbs too much CO₂, the water becomes acidic. Think of it like squeezing lemon juice into a glass of water. It's highly destructive to sea life. So that's exactly where tech-based vacuums come in. We are talking about direct air capture machines. These are literally giant sky vacuums with massive fans that strip CO₂ out of the air and pump it deep into underground rock formations permanently. There's also this thing called BECCS, bioenergy with carbon capture and storage. This is a brilliant hybrid. You grow plants that absorb CO₂, you burn them to create energy, but then you capture the smoke and lock that carbon underground. It's like borrowing carbon from the sky to power our homes and then burying it so it can never escape.
Section 3, the geospatial smart map. So we're planting forests and we're building giant sky vacuums. But that raises a pretty massive question, doesn't it? How do we actually know these carbon removal projects are working? We need strict accountability. Now, what's really interesting about this slide is how these 5 elements actually combine to create an invisible geospatial smart map of our planet. We've got satellites orbiting high above, constantly taking pictures and even measuring CO₂ levels directly from space. We have GPS pinpointing exact locations on the ground. We have drones flying low over forests to check tree health. And all of this massive data feeds right into GIS, Geographic Information Systems. GIS acts as the ultimate smart map, layering all this real-time data together so scientists can see exactly what's happening anywhere on the planet without even having to physically be there. Section 4, auditing the Earth. Having a smart map is incredible for sure, but let's transition to the practical application here. How do we use these tools to actually audit the Earth and verify all these environmental efforts? Well, the life cycle of carbon auditing happens in 3 clear steps. First, we use satellites to pinpoint the perfect spots. That could be finding degraded land that's ideal for planting a new forest, or maybe identifying the exact right underground rocks for storing captured carbon. Second, we monitor health from space. We're checking if those new trees are thriving or, if illegal logging is taking place. Third, we measure and verify. This whole process relies on what experts call the 3A approach: awareness of what's happening, action to manage it, and anticipation for future improvements. By using this approach, we can mathematically prove exactly how much carbon is actually being pulled out of the sky.
But as amazing as this technology is, it's not perfect. Here's a really surprising fact. Satellites actually have blind spots. While they're incredibly powerful tools for tracking global data, sometimes something as simple as heavy cloud cover can completely blind our high-tech measurements. Interestingly, data has also shown that the tech struggles to accurately monitor areas impacted by complex terrain changes, things like volcanic floods. So while we do have a pretty great eye on the sky, nature can still find ways to hide from it.
Section 5. Geoengineering, fact versus fiction. Let's move to and see how this builds into the next big question. What happens if carbon removal just isn't fast enough? This brings us to a highly debated, incredibly high-stakes frontier: deliberate climate intervention.
Solar radiation modification, or SRM, is currently a theoretical, experimental research concept. The idea here is to inject reflective particles, like sulfur dioxide, high up into the stratosphere. Why? To bounce a portion of the sun's light back into space, thereby cooling the planet. I know, it sounds straight out of a science fiction movie, but it's actually inspired by nature. When large volcanoes erupt, think of Mount Pinatubo back in the 1990s, they blast millions of tons of ash and sulfur into the sky, and that has a documented temporary cooling effect on the entire globe. Scientists are basically studying if humanity could actually replicate that effect. Now, because this concept involves manipulating the entire Earth's atmosphere, it has naturally sparked intense public debate and, unfortunately, a lot of misinformation. It is absolutely crucial we separate the documented science from the unsupported claims here. Legitimate peer-reviewed risks of SRM being studied by scientists right now include potential depletion of the ozone layer, shifting global precipitation and monsoon patterns, and something called termination shock. That basically means if we start doing this and suddenly stop, global temperatures could violently spike. On the flip side, unsupported claims, like secret large-scale mass spraying operations commonly referred to as chemtrails, well, they just have no credible evidence. Similarly, claims linking geoengineering research to a rise in Alzheimer's disease via nanoaluminum, those are not supported by toxicology or atmospheric science. It is vitally important that we focus on the actual serious risks of this theoretical technology without getting distracted by the fiction.
Section 6. Governing our climate future. Shifting from the science of geoengineering to the massive international policy challenge it presents, this brings us to our final and perhaps most important section.
There's a saying out there that SRM is a stress test for global climate governance systems. Geoengineering is absolutely not a magic fix for climate change. It doesn't solve ocean acidification, and it doesn't reduce that carbon blanket we talked about earlier. Instead, it is a profound governance challenge. Think about it. Who gets to decide to deploy it? Who bears the liability if it alters rainfall in a vulnerable country? Managing this requires unprecedented international transparency, oversight, and accountability before any technology like this could ever be safely considered.
And that leaves us with this final, incredibly provocative question. If humanity actually figures out how to build a global thermostat using these technologies, who gets to set the temperature? It's a massive question of ethics, risk, and global justice that we all really need to be thinking about. Thanks for joining me on this explainer today. I really hope this structured breakdown gave you a clear, powerful understanding of the tools and choices shaping our planet's future. Keep asking great questions, and I'll see you in the next one.